The world of algebra, using symbols and letters. Can we represent every problem using only numbers? Some values are still unknown, and some relationships cannot be shown with numbers alone. In such cases, people began to use letters instead of numbers to represent problems. Algebra grew out of this need. It explores methods and structures for solving equations by representing numbers with letters. Long ago, in ancient Egyptian papyri and Babylonian clay tablets, people were already working with linear and quadratic equations. However, their methods were not yet part of a systematic theory. They were based more on experience and focused on solving specific cases. So, when did people begin to study equations in a systematic way? The starting point was the Greek mathematician Diophantus. In his book Arithmetica, he organized methods for solving linear equations and introduced a way to represent equations using symbols instead of words. However, he did not yet clearly distinguish between known values and unknown values. After this, algebra underwent a major transformation. As Greek mathematics spread to the Islamic world, new perspectives were added. In particular, the Arab mathematician al-Khwarizmi introduced the concept of algebra and presented a system for solving equations by rearranging terms. The word algebra comes from this idea. Then, when did the symbols we use today, such as plus, minus, times, divided by, and equals, begin to be used? As people tried to express mathematics more briefly and clearly, symbols emerged naturally. Turning long explanations into simple symbols is like compressing a long sentence into a single formula. The French mathematician François Viet played an important role in representing mathematics using symbols. He used uppercase consonants for known values and uppercase vowels for unknown values. Symbolic algebra was later developed further by René Descartes. He made it common to use A, B, and C for known values and X, Y, and Z for unknown values. Now, equations began to be treated not just as calculations, but as a kind of language. But can we solve every equation? Linear and quadratic equations can be solved with relatively simple steps, and cubic and quartic equations also have solutions, although they are more complex. However, as the degree becomes higher, the situation changes. From this point on, mathematicians shifted their focus from how to solve to whether a solution exists. This question led to the development of the fundamental theorem of algebra. Gauss proved that every polynomial of degree n has exactly n solutions when complex numbers are included. This became a foundation for polynomial equations. However, the existence of a solution and the ability to find it are very different matters. In the 19th century, the Norwegian mathematician Abel showed that some equations cannot be solved using algebraic methods. The French mathematician Galois, while studying the conditions under which polynomial equations can be solved, developed key ideas that later became part of modern abstract algebra. So, where is algebra used today? Linear algebra, a branch of algebra, is a core foundation of computer science, artificial intelligence, and machine learning. In physics and engineering, systems of equations are used to analyze complex phenomena such as fluid dynamics and structural analysis. For example, CT scans used in hospitals create images of the inside of the body by sending X-rays from many directions. The data collected from each direction forms an equation, and together, they form a system of equations. By solving this system and turning the results into images, we can understand internal structures without directly seeing inside the body. Even in technologies that seem completely unrelated, mathematics is quietly at work. Algebra, which began with letters and symbols, has become a language that shapes our lives.